Hello everybody and welcome back. So in the last video we started off the 2014 Csmc. We're going to keep things rolling. We're going to jump right into question number 2. Still in part A, so we just need our final answer. So that's what we should be focusing on getting our final answer as fast as possible. That way we can move into B part with the justification. Usually those questions require a little more experimentation. They require more time. So we want to give that to our future selves by solving part A as quickly as we can, while still trying to earn part marks with justification, little bits of justification to earn part marks in case we screw up. But that's enough talk. Let's take a look at question number 2 in the 2014 paper. So in a jar, the ratio of the number of dimes to the number of quarters is 3:2. If the total value of these coins is $4, how many dimes are in the jar? Okay, simple enough question, and then we have a little bit of explanation for those of us who aren't Canadian or American or really don't use dollars and cents in their monetary system. Each dime is worth 10 cents, each quarter is worth 25 cents, and each dollar is equal to 100 cents. So that just helps us out. These contests are written around the world, so a little explanation there is quite helpful for our foreign friends. So, dimes to quarters is 3:2, and we know the total value of all these coins is going to be $4 or 400 cents. Let's take a look at how we might approach this problem. So we can start off with some variables. So we let D be the number of dimes, and Q equal the number of quarters. Okay, well then, $4 is going to be 10 cents times the number of dimes plus 25 cents. We have a quarter, not a fifth of something. 25 cents times the number of quarters. Now, this is sort of using mixed units, so what we might say is 400 cents, and we can drop the cents, is 10 times the number of dimes plus 25 times the number of quarters. That's what the final statement in the question is telling us. $4 is the total amount of all the dimes and all the quarters. Each dime is 10 cents, each quarter 25 cents. What we've done is just we've put them all in the same units. Everything is in cents now. Okay? But we still don't know what the number of dimes and the number of quarters are, but we know that there's a relationship between them. So we can go back to the question, we can double check. We want to know how many dimes there are. So it might be a good idea to put everything in terms of the number of dimes, D. So can we solve for Q, the number of quarters, in terms of the number of dimes? Well, we know the ratio between D and Q, and that can certainly help us. The ratio of dimes to quarters is the same as the ratio of 3:2. So that means if we divide the number of dimes by the number of quarters, we should get the fraction 3/2. Okay? We can rearrange this to solve for Q in terms of D. Then we'll sub that into this equation right here, solve for D, and we'll be home for supper. All right, so we can flip this, and we get Q divided by D is the same as 2/3, right? We just inverted this equation. We flip to the one side. Whatever we do to one side, we have to do it to the other side. That's okay. And now we can multiply by D on both sides and get Q is 2/3 the number of dimes. That's fantastic. So now we have Q in terms of D. We can substitute that in. We could label that as equation number 2, and we could say this is equation number 1. So 400, 10 times the number of dimes, plus 25 times 2/3 the number of dimes. Okay. So what do we have there? 10 dimes, and then we have 50 over 3 dimes. We can get a common denominator there. 30 over 3 dimes plus 50 over 3 dimes. So that's 80 over 3 dimes. $400 is 80 over 3 dimes. We want to just get the number of dimes, and then we're done the question. So what we can do is we can cancel out this 80 over 3 by multiplying both sides by 3 over 8. So 3 over 80 multiplied by 400 should be the number of dimes. Well, that cancels out with that, and we're left with a 5. So 3 times 5 is the number of dimes. So 15 is the number of dimes. $15 dimes in the jar. I think it was a jar. Was it a jar or a piggy bank? Okay, they're in the jar. All right. Now, if we had time, or if we were not confident that we could answer all the questions in B, we don't want to bother trying, what we could do is double check this answer by making sure it's correct. This is our number of dimes. Well, we can use equation number 2 to work out the number of quarters. Okay, see, does that make sense? Well, 2/3 of 15, that should tell us that we have 10 quarters. If I have 15 times 10 plus 10 times 25, do I get 400? So we can double check just to make sure that our answer D does make sense and it does satisfy both equations. It's just a little check we can do. I know it takes a little bit of time. We could even write out the check if we wanted to. And so if you're confident in your answer, you don't have to do that. You can just move on. 15 is our final answer. And all this other written justification is just for our purposes. But if you know you're limited on the contest, maybe you're in the 11th grade and you're not quite ready to try the really difficult questions, what you can do if you have time is you can go back and double check and make sure the answers that you did write down are correct. Okay. But that about does it for question number 2. So we can move right on into the next video for question number 3. It's been Root Beer, and it's been a pleasure here talking to you guys, doing some math with you. I'll see you for question number 3 and more math.